Once you have completed these 4 problems over here, you can continue the video to go over the solution here. In part 8, when we have this division problem, the first thing we want to consider is the denominators are not equal to 0, and still we want to make sure whatever we are dividing by is not 0 either. So based on all these conditions, we want the 5x squared plus 10x to be non-zero. We also want 3x squared minus 9x to be non-zero. Lastly, the 2x squared minus 6x to be non-zero over here. And with this, we can look at the first one. We can factor GCF of 5x. That leaves us x plus 10 doesn't equal to 0, so x doesn't equal to 0, and x doesn't equal to negative 2. For the second one, we can factor out 3x, leaving us x minus 3. And again, we have x doesn't equal to 0, and we also have x doesn't equal to 3. And the last one, if we factor out GCF 2x, we'll get x minus 3 again. So we will have exactly the same domain result as the previous one. So we would get x doesn't equal to 0 and x doesn't equal to 3. So altogether, the domain restriction would be x such that x doesn't equal to 0, negative 2, and x doesn't equal to 3. So now we can go ahead and start working with the operations over here. So a lot of the components are already factored as is. So we can go ahead and start factoring the first numerator. That's a difference of squares, which turns into x plus 2, x minus 2. And everything else had been factored through the process of solving for the domain restriction. So we get 5x times x plus 2, and we can turn the division into a multiplication, which means we switch the numerator and denominator. So now the numerator should be 3x times x minus 3. Denominator would be 2x times x minus 3. And you can see why they would have the same domain restriction, because we have a lot of the same factors on top and bottom in the second rational expression. Here we can right away start cancellation. X minus 3 cancel out, x and x cancel out, and x plus 2 cancel each other out. And I think that's it. And when we cancel x minus 3, we need to make sure x doesn't equal to 3. And when we cancel x, x doesn't equal to 0. When we cancel x plus 2, x doesn't equal to negative 2 over here. So these are the restriction we got. And then for the final answer, we're left on top with 3 times x minus 2. On the bottom, we're left with 5x times 2, or 10x in this case. And now if we look at the domain restriction, we still have a factor of 10x, so we want to make sure that doesn't equal to 0. So at the end, the domain would be x such that x doesn't equal to 0. So the change of the domain restriction happened for negative 2 and 3. They're not in the denominator anymore once we simplify. Moving on to part B, we start with the same process. We want to make sure 5q squared doesn't equal to 0, and we also want to make sure whatever we're dividing by doesn't equal to 0. So 5q squared doesn't equal to 0 means q squared doesn't equal to 0, or q just doesn't equal to 0. Second restriction, we want to take the square root of both sides, so q minus 4 doesn't equal to 0, and q doesn't equal to 4. The domain becomes q such that q doesn't equal to 0, and q doesn't equal to 4. And when we want to rewrite this whole thing, we can write it as 3q squared minus 10q minus 8 over 5q squared. We can flip the division into multiplication, being 1 over q minus 4 squared. And once we get to this form, we can try to factor the first numerator using the AC method. So here we get a times c, which would be the product, is 3 times negative 8, so negative 24. And we also want to make sure the sum is equal to negative 10. Since you've already tried it, you will find the two numbers will be, in this case, negative 12 and positive 2. Because they multiply to be negative and add up to be negative 10. And all this means that we can rewrite the numerator to be 3q squared minus 12q. plus 2q minus 8. And let's group things together. The first two go together, last two go together, and connected by addition. And let's keep everything else as is. Continue on the top, we can factor out the GCF of 3q from the first group, leaving us with q minus 4. Factor out a positive 2 from the second group, leaving us with q minus 4 again, all over 5q squared. And at this point you could start multiplying everything straight across as well to combine the two rational expressions. So in the denominator I really have q minus 4 squared being multiplied by 5q squared. And on top it doesn't change because we only have 1 as a numerator for the second expression. Now on top I really end up with 3q plus 2 times q minus 4 all over 5q squared times q minus 4 squared. So now with a cancellation we can cancel out q minus 4, and that's based on the fact that q doesn't equal to 4. That's what allowed us to cancel. So as a final result we are left with this expression over here. There's not much other cancellation we can do anymore. So we would get 3q plus 2 all over 5q squared times q minus 4. So if we look at the final domain, we will still have the same domain restriction, q such that q doesn't equal to 0 and q doesn't equal to 4 over here, because we still have a factor with q and a factor of q minus 4. And we can say the domain remained the same. Lastly, for parts C and D, if we move on to the next part, we start the same way with setting up the numerator, the denominators to be non-zero, and the denominator and the numerator of the second expression to be non-zero as well. So I'm just going to set up the inequalities first. And here we get x minus 5, x plus 3 doesn't equal to 0, so x doesn't equal to 5, x doesn't equal to negative 3. And let me just move this up so I have more room later on. X squared minus x minus 12 doesn't equal to 0, gives us x minus 4, x plus 3 doesn't equal to 0. So x doesn't equal to 4, and x doesn't equal to negative 3. And lastly, we have this AC method problem for the numerator, 2x squared minus 3x minus 20 doesn't equal to 0. So to use the AC method, we want the product to be equal to a times c, which is negative 40. We want the sum to be negative 3. You should find the two numbers to be negative 8 and 5. So that means I can rewrite this to be 2x squared minus 8x plus 5x minus 20 is not equal to 0. And let's group things together, connected by addition. And for the first group, we have a GCF 2x times x minus 4. Second group, we have a GCF of 5. Left us with x minus 4 again, and that's not equal to 0. So to write in the factored form, 2x plus 5 and x minus 4 doesn't equal to 0. So we can solve each linear equation and get x doesn't equal to negative 5 over 2 and x doesn't equal to negative 4. So now let's combine all the restrictions over here. That's going to be the domain. X such that x doesn't equal to 5, doesn't equal to negative 3, doesn't equal to 4. Negative 3 is a repeat, so we don't have to write it. And then we have negative 5 over 2. And lastly, we have negative, actually we have positive 4. I solved it incorrectly. So we have a positive 4, which is something we've already listed. So that would be the domain restriction over here. And with this, we can start working with this operation. And in this case, if we look at what's on the numerator, this again would be an AC method problem, so we could go through the AC method first, just so we have the factored form to start with. Here we want the product to be equal to 2 times 15, which is 30, and sum to be negative 13. And if we want the product to be positive, that means both numbers need to be the same sign, and the sum is negative, that means both numbers are negative. So we get negative 3 and negative 10. So I can rewrite everything to be 2x squared minus 10x minus 3x plus 15 over here. It doesn't matter whether you write negative 3x first or negative 10x first. You'll get the same result. I just like to write negative 10 first because I feel like there's more GCF to factor out. That's the only reason. And the first group, if we put them together, and the second group, put them together. The first group, we will have a common factor of 2x, leaving us x minus 5. Second group, we have a factor of negative 3, leaving us with x minus 5 as well, as you should expect. And then we have a result of 2x minus 3 times x minus 5 as a factored form. So now our original problem really is 2x minus 3 times x minus 5 over x minus 5, x plus 3, multiplied by, flipping the numerator and denominator, we have x minus 4, x plus 3 over x minus 4 and 2x plus 5. So I'm just looking to the left side of the line to see all my factorization. And once we have this form, we can start the cancellation. Here we can have x minus 5 cancelled out. That's relying on x doesn't equal to 5. And x minus 4 cancel out. That relies on x doesn't equal to 4. And x plus 3 canceling out, relying on x doesn't equal to negative 3. And lastly, we are just left with 2x minus 3 all over 2x plus 5. So if we look at the domain restriction over here, we would actually have just the domain based on 2x plus 5 doesn't equal to 0. So altogether, we would get that x such that x doesn't equal to negative 5 over 2 is going to be the domain. And this comes from that. So if we think about what changed compared to where we started, we have 5, negative 3, and 4 that we used in the middle in order for cancellation, but they're not left in the final answer anymore, so they're not the domain restriction for the last expression that we see. Now for part D, we can do the same thing. Here we get in the denominator 6t squared plus 25t plus 25. We don't want that to be 0. I'm going to leave more room because it's AC method. And the second denominator, 14t squared minus 31t minus 10 doesn't equal to 0. And lastly, we don't want the second numerator to be 0 because we would be dividing by 0 otherwise. So okay, let's look at the AC method parts. Here for the first one, we want the product to be a times c, which is 6 times 25, or 150. We want the sum to be 25. And if we want to have that result, we can think about the factors of 150, which turns out to be 15 and 10. So if we have the number being 15 and 10, that means we can rewrite the expression to be 6t squared plus 15t plus 10t plus 25, and we don't want that to be equal to 0. So let's do the factor by grouping. So the first group has 3t in common, leaving 2t plus 5. Second group has 5 in common, leaving 2t plus 5, which is equal to 3t plus 5 times 2t plus 5 over here. And we don't want this to be equal to 0. So that leaves t doesn't equal to negative 5 over 3, and t doesn't equal to negative 5 over 2. These are the restrictions. We have a bit more fractions to work with this time. And now moving on to the second restriction over here. We again can use the AC method to see whether we can find the factorization. The product here will be 14 times -10, which would be -140, and then we need the sum to be -31 over here. I believe the two numbers are 35 and 4, or rather -35 and +4 in this case. And if we rewrite it, we get 14t squared minus 35t plus 4t minus 10 doesn't equal to 0. Same trick as before, parentheses for grouping and connect by addition. For the first group, we have 7t factored out, leaving us 2t minus 5. For the second group, we have 2 taken out, leaving us 2t minus 5 again. And then we have 7t plus 2 times 2t minus 5 doesn't equal to 0 over here. And as a result, we get t doesn't equal to -2/7, and t doesn't equal to 5/2. In this case, it's a +5/2 based on our factorization. Now moving on to the last one. The last one is a linear inequality, so we get t doesn't equal to 8. So we can see we have all these different restrictions we want to list out for the domain. So it's t such that t doesn't equal to -5/3, -5/2. We also have -2/7, 5/2, and 8. These are all our domain restrictions to start with. And once we're down to this, we can start working out the operation. And for the only part we didn't factor, we see it's 3t squared minus 19t minus 40. That would be an AC method problem, so I'm going to work with that first. And here I want a product to be 3 times -40, which is -120, and I want the sum to be -19. So I'm thinking about factors of 120, which would be 24 and 5. So incorporating the signs would give me -24 and +5 being the factor pair. And this is again a process that will get faster as you do more practice with factor pairs. So when I'm doing this on the spot, that's because I practice a lot with factoring, and it'll come through for you as well if you do more problems. And now that we know these numbers, we can say this original expression is really equal to 3t squared minus 24t plus 5t minus 40. So group the first two together, last two together, connect by addition. So the first group has 3t in common, leaving t minus 8. Second group has 5 in common, leaving t minus 8 as well. So the factoring ends up being 3t plus 5 times t minus 8. And as a result, we can start working with the operation finally. We have 3t plus 5, t minus 8, all over 6t squared plus 25t plus 25, which we factored out to be 3t plus 5 times 2t plus 5. And we can turn the division into a multiplication. In the denominator, it's just 8 minus t. On the numerator, we factored the original denominator, which was 7t plus 2 times 2t minus 5. So I'm just referring to what I have on the right side already. And now we can go through the cancellation. 3t plus 5 doesn't equal to 0 is equivalent to saying t doesn't equal to -5/3. And then I have this factor that I get t minus 8 and 8 minus t. Again, in case you don't recognize they are related to each other, you can factor out a negative sign from the denominator, and you will see they're exactly negatives of each other. So you will have a factor of -1 left. Just put the -1 on either side. And that cancellation is based on the fact t doesn't equal to 8 over here. And then we have everything else being different, so we're just going to leave them as is. So we can say for the final result, I have 7t plus 2. Oh, don't forget the negative sign, the factor of -1. You can leave the negative sign out front. And this is all over 2t plus 5 in this case. And the only denominator I have left is 2t plus 5 doesn't equal to 0. So based on this, I have t doesn't equal to -5/2 as the only domain restriction that I am left with in the final result. And if you compare what we started with, we had to use t equals -5/3 to cancel things out. We had to use t equals 8 over here. And we also notice that we don't really have -2/7 in the domain restriction anymore because we have this in the numerator. And lastly, we have the +5/2 that kind of went a little unnoticed as well. So that's how the domain restrictions changed from the starting expression to the ending expression.